the smell physiology, the olfactory pathway. It has 5 places, 5 station. First station starts at something called as olfactory neurons. Now these olfactory neurons are present inside your nose, okay? And these olfactory neurons are receptors for smell, okay? And these are bipolar. It means they connect to 2 places. First place they connect to is olfactory bulb. Second is olfactory epithelium. Very important, because olfactory epithelium gives rises to a lot of nutrition. So we need this connection. We need this bipolar neuron. So what happens is that there are basal cells as well. What are basal cell? These basal cells are just stem cells for regeneration. If somehow from some disease your olfactory neurons are damaged, so these basal cells will give birth to olfactory neurons, and then your olfactory neurons will be well again. What is stem cell, by the way? Stem cell is this. Okay, I'll try to define it normally. These cells that produce some cells, right? They have some product, and in the last stage what happens is that the population of the original cells stays same and new cells are made as well. But in mitosis, one cell goes into 2, right? So basically the stem cells are like, if for example we have 2 stem cell and they make 4 baby or daughter cells, what happens is that these 2 cells will stay 2 forever, and this 4 will also stay like this. So basically they are regenerating, right? Okay, this was the concept of stem cells. Okay, so what happens? Olfactory neuron, bipolar, 2 places. One goes to olfactory, one goes to bulb. But this bulb, right? This olfactory neuron innervates olfactory bulb via, what is this? It is the cribriform plate. What is cribri? Cribri means sieve. It's like a strainer, and this strainer is like a bone in ethmoid, right? And it's like a strainer, holes, multiple holes. Via these holes the bipolar cell is moving. The bipolar olfactory neuron is moving, and it's innervating the olfactory bulb. And then this olfactory bulb eventually connects to thalamus and limbic system. Cool thing is that smell is directly connected with the cortex, okay? It bypasses thalamus normally. Normally, smell pathway bypasses thalamus. But for conscious perception of smell, for the conscious perception, we need thalamus. So for conscious perception, thalamus is included in the pathway. But for unconscious perception, the thalamus bypass, so the smell bypasses the thalamus. Okay, so we were at this olfactory bulb. Olfactory bulb has 4 cells, right? What are these 4 cells? Olfactory bulb has 4 cells: tailgate and procession guards. Tailgate is T and G. T and G. Okay, mitral. Okay, okay, wrong. Okay, let's change this. Wait. Let's remove this. Okay, no problem. Okay, so olfactory bulb has 4 cells: 2 excitatory, 2 inhibitory. We need inhibitory to control excitatory. We need excitatory to control inhibitory. This is the balance. So olfactory has 4 cells: mitral, tufted, granule, and periglomerular. Periglomerular use GABA neurotransmitter. This is inhibitory. How GABA works? GABA works by increasing chlorine ions, and this is how they increase the negativity of the cell, right? What about how they work? They work by glutamate. Glutamate is excitatory. It opens up Na. Okay, it opens up Na. It opens up Na channels. So a lot of Na comes in. cell becomes excited. RMP goes from negative to positive. This is how this thing works. What about these cells? This cell is called sustentacular cells. Sustenance is called hold up. The word sustenere, it means to hold up. So it means they are holding up something. What are they holding up? What do you think they are holding up? They are holding up these all cells. So we call them sustentacular cells. What about Bowman cells? Bowman gland. Bowman gland secretes mucus so that it can attract dust particle and dirt from your nose, right? That's how the mucus is secreted from Bowman's gland. Okay. Olfactory. From olfactory, the impulse goes to thalamus and limbic system. Limbic system is for emotions and memory. Thalamus, I will tell you what thalamus does. Okay. So via thalamus, the impulse after this goes to dorsomedian nucleus. Dorsomedian nucleus, and then this dorsomedian nucleus results in conscious perception of the smell, because this dorsomedian nucleus is connected to olfactory cortex at orbitofrontal cortex. Okay, cool. Limbic cortex. This olfactory cortex goes to thalamus and limbic cortex. This limbic cortex has two parts. First is amygdala, second is entorhinal. So this entorhinal is for memory perception of the smell, and amygdala has for the emotional perception of the smell. Emotions of the childhood. Whenever you smell something, you suddenly remember the smell of your childhood, right? For example, gasoline. For example, smell of petrol. For example, the smell of diesel, right? For me, it's a smell of rain. I just remember my childhood. So this is amygdala, right? What about entorhinal? Well, entorhinal, it's a great name. Entorhinal cortex. I understand this with rhino, which is a smell, a big rhino, enters where? To hippocampus. A gate to hippocampus. And we know that hippocampus is the house for memory. Okay? So when you smoke MJ, when you smoke cannabis, this entorhinal cortex is activated a lot. When you smoke amygdala, when you smoke cannabis, again the amygdala is also activity goes through the roof. So you have a lot of lot of emotions, right, coming. So this is how the limbic cortex works. What happens afterwards is that all of these places, they eventually come to this place called olfactory cortex, which is present at where? Orbitofrontal cortex. And this gives rise to conscious perception of the smell. But for unconscious perception of the smell, the thalamus is bypassed. And this orbitofrontal cortex makes the decision if it's a good or a bad smell, if it's a good smell or if it's a foul smell, right? Here orbitofrontal cortex does this decision. Okay, what about this thing? Well, this thing called entorhinal cortex is the earliest area to undergo degeneration in Alzheimer's disease, because the memory of your ex, you might want to forget about your past lovers, right? So that's why this is entorhinal cortex is the first region to degenerate under the disease called Alzheimer disease. Cool. And Alzheimer disease depends upon acetylcholine, because A for acetylcholine. Okay, why? Well, the exact mechanism is still unknown why this is the first one, but I think why it's like this, because entorhinal cortex has a buildup of tau tangles. These are like pathologically markers of this disease. Okay, tau tangles on the gates of this entorhinal, and then this gate is destroyed to hippocampus, and then eventually the memory in this disease fades away. So this is the story of Alzheimer in communication with entorhinal cortex. Okay, cool question. Why you think something is disgusting smelling, and why some smells are amazing, and why some people love disgusting smells? Okay, well, the thing is, disgust and pleasure are not really opposite. They are intertwined deeply. How? For example, when you smell something disgusting, it's really a challenge for the brain. Okay? And brain loves new. Brain loves adventure. Brain loves challenge. So we love this challenge. Same as horror movies, right? Smell is neither good nor it's bad. It has a value depending upon your past memories. Okay, so if a smell is related to some sort of past trauma, it will be a bad smell, and it is decided unconsciously, by the way. What about other thing? Cultural conditioning. In some culture, garlic smell is amazing. In other culture, garlic is insanely horrible. So cultural conditioning is very important. Smell is a sign of nutrition for a lot of people. Whenever rain is coming, they think they're gonna have a good feast because of the farms. So this is also a mechanism why they love the smell of the rain. Smell of the rain. What about biological info? Well, sometimes people love the smell of their partners, and the smell of this partner actually suggests that they are compatible or they are not compatible. If you don't love the smell of your partner, you should probably change the partner, because it suggests that you guys are not really compatible. So this is why we love disgusting smell. In real world, there is nothing disgusting and nothing amazing. There is no disgusting smell and no beautiful smell. This is just your memories or just your reflexes. Okay, what about taste? Well, the sensation of taste is called gustation, right? We have 5 sort of sensation. First, sweet, salt, sour, bitter, and then the last one, the really addictive one, is umami, which I love personally. So sweet one, the receptors on your tongue for your sweet one is T1R. Actually, it's not just T1R. They work in a couple. T1R2 and R3, they work together. If they are like alone, they will be useless. So we need the dimer of these two receptor, and we know that couples, they look sweet. So this is how I remember: T1R2 plus T1R3 for sweet taste. If they're alone, they're useless. So we need both of them. What about salt? Salt, we know NaCl is table salt, right? So Na, so epithelial Na channels, ENaC receptors are for salt. Sour, whenever you see someone eating sour, they make a funny face, right? They make a funny face because the expression of their face changes, and it's so funny whenever you give sour tasting candies to a baby, right? So what are the receptors for sour? It is hyperpolarization cyclic nucleotide channel, which is HCN. Do you remember HCN? HCN produces funny current, right? Funny current channel. This is Na channel openers. Okay, so funny current, HCN, sour, funny, right? Bitter. It's amazing how nature has given this taste. How? Because if you taste anything bitter, it is usually poisonous in nature. Even in toxicology, we can understand a lot of toxins, they taste bitter. So if it tastes bitter, it's a poison, it's a toxin. What are the receptor for toxins? T2 receptors. Okay, T for toxin, T2 for toxins. Okay, what about umami? Umami is how to explain you this taste? Umami is like sweet plus salty, but it's different. This taste is present in tomatoes. tomatoes. And this taste is because of presence of glutamate, a chemical. And this chemical can be chemically, artificially be synthesized and is sold in markets called MSG salt. MSG salt. A lot of people, they call it Chinese salt or Japanese or I don't know. They just call it Asian salt. I call this makes shit good. That's it. So MSG, wherever you see M, glutamate, and glutamate receptor 4 are the receptors for umami. It's highly addictive because it tastes amazing. It tastes amazing, really great. So that's why it's really addictive. It works on dopaminergic pathways. That's why it's really addictive. Okay, glutamate receptor 4, M-glut R4. This is receptor 4. This is the name of receptor of umami. Okay, what about taste buds? Well, this is how a normal taste buds look like. It has bunch of bunch of cell bodies and then axons like this. So these taste buds have 4 type of cells. Type 1 is glial cells, the supporting. Type 2 is the taste receptor cells, the very own taste receptor cells. Type 3 is presynaptic cells. Presynaptic cells means, what is a synapse? Synapse is axon, cleft, postsynaptic. This is another neuron. This is one neuron. Neurotransmitters going to from one neuron to another. This is presynaptic. Okay, this is a synapse. I hope you understand me. So type 3 is presynaptic. Type 4 is basal cell. We know that basal cells are for stem cells. Even in nose, basal cells are for regeneration. Here for taste, basal cells for regeneration as well. We need them because we need regeneration. We need regeneration after a hot cup of coffee. Okay. Taste pathway. The pathway. This is your tongue. Okay. This is your mouth. This is your tongue. The posterior 1/3. This diagram is a little bit disappointing because posterior 1/3 should be a little bit like this. It's less in area. Okay, it's more backwards. So there are 3 nerves there are 3 nerves that are innervating this tongue. Okay, this tongue of yours. Posterior 1/3 is innervated by 9th cranial nerve called glossopharyngeal nerve. And this glossopharyngeal nerve literally means, glosso means tongue, pharyngeal means throat. So tongue, throat. So the tongue, throat here as well, this area is innervated by cranial nerve number 9. So this posterior 1/3 is innervated by glossopharyngeal, which is tongue, throat nerve. This anterior, this part, is innervated by something called as chorda tympani. It's a part of a facial nerve number 7. Cool. What about the palate of your mouth, the pharynx and the palate, this part, the big part? Well, for innervating this big part, we need a big nerve, and this big nerve is vagus nerve. Vagus in Latin, it means to wander, it means to travel, right? It means to that's why they named the city Vegas, because you want to go there. So that's why it's named Vegas. So this whole palate is covered by vagus. So we have nerve number 9, nerve number 7, and nerve number 10. Okay, cool. What about this nerve, CT, chorda tympani, nerve number 7? This carries a lot of parasympathetic fibers, the fibers that are activated when you're not stressed, when you're enjoying your life, when you're not stressed. And when you're not stressed when you see a lot of food. You're excited to see food because a lot of dopamine is gonna hit, and then you start salivating, right? And then when you go to sleep, your body also goes into parasympathetic system, right? And that's why you have watery mouth or saliva coming out of your mouth when you're sleeping. And this is the reason why this happens. because this chorda tympani, the cranial nerve number 7, actually innervates the this anterior part of your tongue, right? That's why. So these impulses, they go to a common nucleus called nucleus tractus solitarius. N9 T10 S stands for 7. Nucleus tractus solitarius, NTS of medulla. Medulla is behind you, behind your mouth, just behind your mouth. This is the integration center of your taste, and after this common nucleus, it goes to thalamus, the relay point, ventro-postromedial nucleus of thalamus. After this, the impulses goes to your taste center. The taste centers in your brain are anterior insula and frontal operculum. So this was the whole taste pathway of your body.